For tomorrow's test, expect to see something where I see that you can do this from scratch. You already quizzed on it. And yes, I will go over 4 and 8. In fact, I can start there. But let me make sure you're clear on tomorrow's test. You're going to have only one problem that I expect you to do from scratch with Taylor formula, because I don't want to grade any more than that. And this is, for some of you, your second chance to get this right this time. For those of you who got it wrong on the quiz, it's worth more points when it's on a test than on a quiz. Then I want to clarify to you that if you look at the directions on 2, 3, and 4, they all start with using a known Maclaurin series. If you see that underlined, I'm trying to emphasize to you while you are in the middle of a test for clear directions that you are going to begin with either your Maclaurin series for sine x, e to the x, or cosine x. And then you're going to begin the manipulation to create what is being asked for. Know that that is what is expected. Then make sure that you read the directions. First for non-zero terms, general term, or sigma form, or whatever the directions say. Let me erase. Then as you take a look at numbers 5 and 6, I'm giving you a sigma formula for a particular function, and then I'm telling you what to do, and I want to see that you can do that with your sigma. Now, if you happen to do, oh, I will admit, yes, the 5th degree was a little harsh. And I need to be careful of what I give you to test on so that it isn't my burden to grade. But notice with these problems that I'm asking you to manipulate or do those operations in proper order to your sigma. If you decide to write out a few terms of sigma and go through the operations, that's okay, but know that you have to finish by writing the answer in the formula, in the sigma formula. And then I want to point out to you that number 7 is something we quizzed on, and number 8 is something we quizzed on. So if those show up, it's possibly your redemption time if you didn't get them right on the quiz. And then I'll go over those problems with you. But I just want to clarify for you, the test tomorrow is going to be of similar format. Just might be a little bit less time because we only have an hour. So you were asking specifically for 4 and 8. So I'm going to start with those, and I'm going to try to make sure that I get through all the problems. If I don't, I will just keep recording until I finish while you move on to 4th period, and then you can look at the recording later. So I will start with number 4. Using a known series, you see that cosine x is in there, so we're going to start with cosine. Keep in mind that cosine is an even function. If you look at the graph of cosine, it's symmetric to the y-axis. It begins with its y-intercept and then has only even exponents, but it alternates positive, now negative, positive, and this is wanting sigma form. So you can either use the first few terms or you can do it in sigma form, and I'll try to show both. You know that cosine is equal to negative 1 to the n. It's even, so 2n. And then you want to realize the order that you need to do this in. Okay, yeah, I'm not going to throw any surprise things at you on a test. So you're not going to see anything that is in a different format than what I have here. And you're going to first substitute 3t in. After you substitute, then you're going to multiply by t. So substituting in 3t, I'm going to distribute. I'm going to do this. I'm going to write 3t squared for what is going on right here. And you need to know that the exponent distributes over multiplication. So you actually have 9t squared over 2 factorial 2. And then when you plug that into a fourth power, you distribute the exponent again. So you have 3 to the fourth power times t to the fourth power. And then 3 to the sixth power, t to the sixth power. And if you're in sigma, we're only substituting into this x. So when I'm substituting 3t in, I am going to distribute the exponent over the multiplication. So it's 3 to the 2n times t to the 2n. So that's just the substitution. Then we need to multiply by t as well. And I'm going to do a lasso and move this over. Come on. Keep going. There we go. So now times t. If you're going term by term, multiplying by another t adds 1 to the exponent. And then if you're looking at it in sigma form, when I'm multiplying by t, I am adding 1 to the exponent. It's very important. I need to see a singleton variable. So what I'm saying is don't write t to the 2n times t and leave it with the variable written twice. You need to use the exponent rule, especially if you're prepping for integration. Now I'm going to do the integration just in the sigma format. And we are integrating the function from the center to x, which means basically just integrate with respect to x if that t was an x. So that integral is going to create all of this as a constant multiple. And then integrating, I add 1 to the exponent. and divide by that new exponent. And let me look at the directions again. The directions asked you to write the Maclaurin series in sigma form, so that would be an appropriate answer. If your formula looks a little bit different, the possibilities are maybe you don't like the +2 sitting around, and if you substitute into every n an n minus 1, and then change this by adding 1 and correctly have that written, it will be the same exact formula and still completely correct. And if you want, I'll write that down real quick. And I'm plugging in n minus 1. So while I can have +1, because it's -1, I should do that. And then that's going to be 2n minus 2. But then these will be so those are equivalent. And that was number 4. Then I'm going to move over to number 8 and go over that one. And with simplifying, you do not have to simplify the constant multiple. With simplification, where the variable is, I want to see that not multiplied with other pieces of the formula, but to have it written where you can show me exactly the variable, maybe plus or minus the center, and the actual exponent that is on that. The rest of it can be as messy as it is. And so with number 8, this is f of x, and we want to know if f of x is a local maximum, local minimum, or neither. You are going to use the second derivative test. Keep in mind that if you try to show this in any other way, it will actually not be adequate, and there are reasons. For one, you do not actually know any derivative values of f of x near x equals -5. You cannot use the first derivative test. You don't actually know that. What you do know is you do not have an x plus 5 to the 1 power. The only way you won't have that is if it's understood that you have 0 times x plus 5 to the first power. And the only way that's going to happen why won't you listen to me? Thank you. The only way that's going to happen is if 0 is the first derivative of your function at the center. You don't have to explain that to me. You just need to write it, and that was -5. Oh, and by the way, I did see in the answers that I used the wrong number in my explanation. And that was just a typo of failing to change when I did copy paste. So you are allowed to flat out just say that the first derivative at the center is 0. You don't need to explain to me what I just explained. I just want to make sure you know why. Then you also need to find the second derivative. And when you look at the exponent 2, You need to make sure that you look at the sign in front of that. That's important because that is part of the coefficient. The coefficient of x plus 5 squared is negative 1/2. And the coefficient must equal the formula second derivative at the center divided by 2 factorial. And that's coming from the Taylor formula. So that means that your second derivative is equal to, if I multiply this over here, I'm going to end up getting -1. And -1 is less than 0. Very, very important. Very, very important. I repeat, very, very important. You need to state that the first derivative of the center is 0, and you need to make sure that you express less than 0 with your finding. The less than 0 is needed to be said to justify your second derivative test. At that point, you're literally allowed to just say, I know what this is, and write it down. You don't have to show me that you realize this says concave down. You don't have to show me that that means that while you're concave down with a 0 sloped tangent line, you are located at a relative local maximum. And you can say local maximum or relative maximum. Rmax is understood to mean the same thing. And that's all you need to say. Okay. So then are there any other particular numbers on the practice test you want me to go over first? That's a good question. Okay, you should say second derivative test. It's a good habit for the AP exam. Do you have to? On AP exam, it depends on how they decide to grade. So my advice is say it. It's best to not leave it open. You have to say what is highlighted in blue. I would recommend that you tell them the test you're using. I'm not going to guarantee that they will mark you down if you don't say it, but I'm telling you that they might. Okay, so I'm not getting any requests for particular problems, so I'm just going to start at number 1. And for number 1, I'm going to save us time and go over to the answers and just point out the answers. With the problem where you are doing this from scratch, you're going to need to make a table or however you organize your information. Keep in mind that when n is 0, it is the function that is there. You're going to have to go through the derivatives, and then after the derivatives are taken, the center needs to be plugged into all of the derivatives. Once you get all of that set up, then you're ready for the formula. Remember that the formula is nth derivative at the center over n factorial multiplied by x minus the center to the power of n. It might help you if you write that down as you're doing the test problem. And then it also helps to remember that the first term is just the value of the function at the center. The second term is just the first derivative at the center multiplied by x minus the center. Then the factorial becomes necessary to bring in. And at that point, we have the nth derivative at the center, and then bring in the divided by 2 factorial x minus center squared. And then all of that divided by 3 factorial times x minus the center cubed, and so on. And yes, I probably went too far by asking you for the 5th degree term. For my sake, on a test, I would only ask you for the 3rd degree term. But you know what? It was a practice test. It was meant to be fun, right? All right. Then for the second problem, 2, 3, and 4 are really asking you to start with the known series. I'm going to save us a little bit of time by pointing out the answers and talking through it that way. So you start off with, this is the series for sine x. These are the first 4 non-zero terms and the general term. Based on order of operations, you need to first substitute in an x squared. When you substitute x squared in, you are multiplying the exponent 2 with the current exponent. And then the next thing you're asked to do is to subtract 5. When addition subtraction comes into play, it's only going to combine with a like term and it will not change the general formula. The general formula is the pattern that is expected to continue from the last term that was written, and that this is what the formula is going to be as you continue on after getting this from some particular n that is plugged in. Addition subtraction does not affect the general term. You always have to add together the terms that are changed and separate that from the full formula. The only time addition subtraction is going to change the formula itself is if you're adding together 2 infinite series. But if you're adding a specific degree polynomial to an infinite series, it only affects however high degree that polynomial is. And so that ends up being all there is. Then moving on to number 3, you're starting with your known e to the x formula, first 4 non-zero terms and the general term. And then you want to think about order of operations. The first thing is you must substitute a negative x everywhere that you have an x. Someone asked me in the last class if they can just start with e to the negative x written down. That's fine, because it is a pretty quick movement from here. By substituting negative 1 in, and then, by substituting negative x in where you see x. Just to make sure you're clear, you are distributing the exponent over the multiplication of a negative 1 and an x to get this formula. And you can see it creates an alternating positive, negative, positive, negative. The next thing you need to do is subtract 1 before you go through the division by x. If I subtract 1, that's going to take out completely that first non-zero term. And it does say first 4 non-zero terms, so that means you're going to need that next term written in. And so there it is with the addition of what was to be the next term brought into play. and it does not affect the general term. Then the last thing is to divide by x. When negative x is divided by x, you get the -1. With x squared over 2 factorial divided by x, it's now just going down one exponent for each of them. In the general formula, if you are dividing by x, you understand that that means subtract the exponents n minus 1. So realize that the manipulation of the series is forcing you to know your exponent rules better than you knew them before. And that's really important. It's one of the things that's being looked at, is your ability to use those exponent rules. And let's see, I had talked through this one, I believe, or no? I did number 4 already, correct? Let me know if I'm wrong, because I'm moving on to 5. And I only wrote the answer, so let me go over here. We are looking for a power series in sigma form. So you're being given a sigma form to start with, and it's asking you to integrate the, find the general antiderivative of h of t. And I'm not going to throw in this sudden change of variable there on the test where it doesn't need to be, but there you go. Now you've got h of t. So you're integrating. Because it doesn't have limits on it, you're going to start with c plus instead of finishing with plus c. And when you integrate the formula, locate your variable, addition, subtraction due to the center, and the exponent. Everything else is a constant multiple that's just going to stick around. And then integral direction is add 1 to the exponent and divide by that exponent. If this were a multiple choice problem, there would definitely be a simplification with this denominator, but you do not have to simplify that part. But it does simplify to 2n plus 1 factorial. For number 6, you're being asked to do a couple of things. I went over this problem with you guys yesterday, but it's worth going over again. So, especially with it being recorded. You want to realize the order of operations. 2x has to go inside g prime, the function g prime. 2x cannot be plugged in until you have g prime. So you want to first be aware that you're going to plug in 2x after you have found the derivative. That's got to be at a later time. Then as you look at the rest, you should see that with the multiplication, you have to first get the g prime of 2x and then multiply that by x cubed. And this gives us an order. The first thing we're going to do is take the derivative, locate your variable and the exponent on that variable, And everything else that has n in it is just multiplying or dividing, and it's a constant multiple. So that stuff is just going to stay. And then taking the derivative, we have bring the exponent down, subtract 1 from the exponent. And if you like, you can change that to n squared. That was first thing. Second thing, g prime of plug in 2x. So I'm going to take the n squared and let me get some of this out of the way so it doesn't interfere. So the n squared, substituting into the x, a 2x, but you've got to separate the multiplication so that you can properly deal with bringing x cubed in. And make sure you guys are keeping an eye on time because my 10-minute alarm has already gone off and we've got 4 minutes of class. Okay. So I'm separating 2 to the n minus 1 times x to the n minus 1. And then I multiply by x cubed as the last step. When I multiply by x cubed, I have to simplify by using the exponent rules of add the exponents. And adding the exponents, n minus 1 plus 3 becomes n plus 2. And it's possible for you to have a shifted form of this, but if it is shifted, then you're starting at a different n. And if you added 1 or subtracted 1, then you will do the opposite to each of these n's. All right. Then we are almost done. I think I might be able to finish. No, stop calling me scam. Actually, it probably wasn't a scam, but whoever it was, I just said no. Okay. Come on, erase. We're going to do this. So this is going to be a second chance at some quiz problems here. When you're looking for the third derivative of 1, you're looking for exponent 3, and you're looking at the entire coefficient. And you can set the coefficient equal to the coefficient Taylor formula, which is nth derivative at the center divided by n factorial. I'm currently working with an n equals 3 because that's a 3. And my center is 1. So that means that the third derivative at 1 is equal to the coefficient times 3 factorial. And you can choose to simplify or leave. To find the 8th derivative at 1, you want to realize that that means you need the number 8 to be the n in a term. That means the coefficient is, with an 8 plugged in, 2 over 3 to the 8th power, and set that equal to the coefficient formula, of the 8th derivative at the center divided by 8 factorial. And just to emphasize, these are what are so important to match. At that point, all you have to do is take that coefficient, multiply by 8 factorial. You don't have to simplify. You can call it a day. And I did it. It's 12:35. Time to move on to your next class. And I finished. Woohoo! Good luck.